Alright, I'm recording section 1.5 for geometry. I have a limited amount of time on the website, so I need to talk fast. You can pause it when you need to. The objective today is learn to describe angle pair relationships. Learn to describe angle pair relationships. Okay, I'm going to go out of order. I'm going to define adjacent angles first. There are three parts to this definition. Two angles that share a common vertex. Two angles that share a common vertex. A common side. So it's let's write it this way. Two angles that share a common vertex, side, and no common interior points. Okay, this word is adjacent. Think of it as next to. Angles that are next to each other. So a picture I will draw here. You have an angle A, B is the vertex. Let's put D on the inner ray and C on the outside. So this angle ABD, angle ABD, and angle DBC. So I'm going to put numbers in here. This angle 1 and this angle 2 are adjacent. They are next to each other. They have all three parts of this definition working. They have a common vertex, a common side, and the points that are the interior here are not in the interior over here. So they have no common interior points. So you have three parts. Common vertex, common side, but no common interior points. All is good on this one. Be careful. I could also write this as angle A, B, C, and angle D, B, C. Now look at the angles that I'm talking about and watch carefully. Angle A, B, C, the big one. Is that adjacent to this angle D, B, C? And the answer is no. This one was up here, yes. The answer is no. They do share a common vertex. They share a common ray right here. Both the large angle and the smaller one share the same ray BC. However, they have common interior points. These points that are in the interior of angle 2 are also in the interior of this large angle ABC. So it fails the definition. So the first one, they're next to each other. The second one, you have one inside of the other. Those are not adjacent. Now I need that definition to go back up here to define complementary. Complementary are two angles whose sum is 90 degrees. Two angles whose sum is 90 degrees. They do not have to be adjacent. So they could be two angles that simply are going to add up to 90. Let's call this angle 1 and this angle 2. However, complementary angles could be adjacent. They could be, here I have a right angle, so I know that they're going to add up to 90. And let's call this angle 1 and angle 2. Now they're not bisected. I didn't mean to make them look like they're congruent. They just add up to 1. They just add up to 90. So here's what I would write. The measure of angle 1 plus the measure of angle 2 equals 90 degrees. Because angle 1 and 2 are complementary. So complementary angles add up to 90 degrees. Supplementary angles are going to be similar. There are two angles whose sum is 180 degrees. So supplementary is 180 degrees. Again, they do not have to be adjacent. They do not have to be sharing a common vertex side and no common interior points. I could have one angle this way and another angle here, They do not share a common side and all. Angle 1 and angle 2. Those I could tell you were supplementary, then you'd know that they add up to 180. I could draw a straight line and put in an angle where angle 1 and angle 2 are supplementary in that one. In this case, the second situation, these are adjacent and supplementary. They add up to 180. Here's what you'd say about this diagram. Measure of angle 1, make that again, the measure of angle 1 plus the measure of angle 2 equals 180 degrees. When they're supplementary, they add up to 180. Now, to remember these two, it might be better to think alphabetically. C comes before S, and then numerically, 90 comes before 180. So the complementary goes with 90, supplementary goes with 180, so that you can get that memorized. Okay, adjacent angles we've done. Let's go to linear pair. Alright, linear pair, by definition, is going to be adjacent angles that form a line. So adjacent angles that form a line. Picture would be straight line, and you have pair, meaning two. So you have two adjacent angles that form a line. Let's adjust this definition and put a 2 out in front. So adjacent angles that form a line are called a linear pair. Notice these are also supplementary and these are also adjacent. So they satisfy three definitions right here in this diagram. So linear pair, think of this as form a line. You see the word line inside a linear pair. Okay, vertical angles. Vertical angles are going to be, I'm defining this different from the book. You can read the book if it helps you to make sense of it. There's a definition there. The one I will use is two non-adjacent angles formed by intersecting lines. You have two non-adjacent angles formed by two intersecting lines. Formed by two intersecting lines. So what I do is I draw two intersecting lines. And then I'm naming the angles 1, 2, 3, and 4. Now the vertical angles are the non-adjacent. Now adjacent means next to. So non-adjacent means not next to. So angle 1 and angle 3 are not next to each other. Angle 1 and angle 2 would be next to each other. So you have right now non-adjacent angles 1 and 3. And that would be your definition for vertical angles. So let's write angles 1 and angle 3 are vertical. Also angle 2 and angle 4 are vertical angles. Okay, let's go to your book. You can pause this till you get ready. Go to page 35. Do these on the back. There are some guided practices that I think would be helpful. And actually I'm going to skip that. I'll come back to this one. I'm going to go to the bottom part. What you can interpret from a diagram. In this diagram you have this point A, then the vertex on the bottom B and C, then D on this ray and E on the other ray. There's a list of things that you can conclude and there's a list of things you cannot conclude. So be very careful. You cannot just assume. You cannot assume things, you have to be sure of them. So what you can conclude in this picture is that A, B, C, D, and E are coplanar. They're in the same plane. You can conclude that points A, B, and C are collinear. Working out some vocab there. You can conclude number 3 here, that angle ABC is a straight angle. And you can conclude that this ray BA, the ray BC, the ray BD, the ray BE, they intersect at E. Intersect at E. Another thing you can conclude is that angle and angle CBD form a linear pair. They form a straight line. That's a linear pair. And then you can also conclude that angle ABD and angle CBD are supplementary. What you cannot conclude for one, is that this segment AB is congruent to this segment BC. We don't know that for sure. It's not marked. Secondly, angle ABD equaling 90 degrees, we don't know that for sure. It's not marked. And number 3, angle DBE congruent to angle EBC. We don't know that for sure. They're not marked. So the key is must mark to know for sure.